This is TWIS, This Week in Science, episode number 549, recorded on Wednesday, January 13th, 2016. Wring it out and wash it. Hey everyone, I am Dr. Kiki, and tonight on This Week in Science, we are going to fill your head with rumors, spite, and sperm. But first...
Disclaimer, disclaimer, disclaimer. Tonight we are entering into a new phase of the show. As I speak, a highly suggestive, albeit entirely subjective, test is taking place. We have added to the broadcast a brainwave frequency that is engineered to elicit a response from our listeners. This frequency is based on a culmination of decades of research into brainwave patterns. Selected for our test is a very unique pattern that seems to be present in most mammals and an occasional member of the bird family, including the barn owl, the common crow, and the blue-footed booby. Also, certain cephalopods have been known to respond. The frequency cannot be heard by your ears, will not disrupt your listening pleasure. And to respond, we are attempting to elicit, the response we are attempting to elicit will not cause you any harm. No harm will come to you. Though if you are driving or operating heavy machinery, you may want to pay close attention to what you're doing, because it's time once again for This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair. And we have a guest who's going to be with us.
And we have a guest, yes. Good science to you, Justin, Blair, everyone out there. Welcome to another episode of This Week in Science. TWIS is here once again. Yes, yes, yes. We're back from New York City. We made it out alive, although Justin might have brought back a few bugs.
I brought them all with me. I'll be incapacitated for a few more days, but then I will be immune to everything.
And you're helping cross-pollinate, so it's fine.
Yeah, once the incubation period is over, we'll see how it goes. Everyone, we have a great show ahead today. On tonight's show, we have an interview in the second half of our show. You can see Dr. William Dichtel down below in our little space of who we are, where we are, our little talking heads. His work this week is published as Nature's cover story. It's pretty cool. We get to talk about it. What have they done? Well, he and his team have developed a material for water purification that is new, improved, and pretty amazing for the entire world. So the possibilities are very exciting, and we are excited to have him here tonight to talk about his work. Also, we've got tons of science news. We love to do that, don't we? I have stories about gravitational wave rumors, the Anthropocene, and the flu. What do you have, Justin?
I have FFing memories and why Big Bird makes us smarter.
I'd like to know that. I love Big Bird. I like big birds. I like Blair. What do you have in the animal corner?
Oh, well, you know how I love alliteration. So tonight I have spite, spectacles, and sperm.
I love it. Okay, everyone. You ready to do this show?
I'm ready? So ready.
So ready. Okay, everybody. How about some rumors first? The rumor mill is running rampant. People are all aflutter, all in a tizzy online. They're like, ooh, gravitational waves. Gravitational waves? Have they been discovered? Have they? Well, you know, here at This Week in Science, if you've been listening to the past few shows, and for the past few years, we have been predicting and not predicting gravitational waves for years, but whether or not they would be found. Every year, Justin's prediction is gravitational waves will not be found this year, right? And I used to predict that they would be found, but then I kind of jumped on Justin's bandwagon, and now I'm predicting also they're not going to be found. But Big
You're both wrong.
experiments. Well, no, we don't know yet. That's the thing. There's just a rumor. And let me ask you, Blair, Justin, what do rumors have to do with science?
Nothing.
Yeah, that would be I'd go with that.
That would be the correct answer. Yes, science. It's not a bunch of rumors. Science is a process, right? Right. So this whole rumor mill, Lawrence Krauss tweeting out there that, oh, gravitational waves, there's this rumor. It's, yeah.
Nope.
No, it's just a rumor. And so the researchers who are on the actual LIGO team, none of them are saying that they have found anything. They are working on a team. And LIGO's Laser Interferometer Gravitational Wave Observatory, it's a big experiment, been upgraded over several years so that it would be a little more sensitive to finding gravitational waves. They turned it back on last year, 2015, which is why Lawrence is probably saying these things. But anyway, nobody on the team has spoken to Lawrence. Lawrence is like talked to somebody who worked on the experiment. Anyway, I'm just telling you guys, don't get excited until the papers come out, until the data is analyzed, until we have peer review.
Mm-hmm.
Yes, until the peer review process has taken place. This is what we are going to wait for. But if it is 2016, okay, I'll eat that humble pie. But not yet.
Not yet.
Not yet. My anti-prediction for gravitational waves has not yet been proven
This
false.
would come just a couple of weeks after we have predicted that they won't be
It'd be pretty early in 2016.
Yeah.
It would be very early. Too early for me. So anyway, rumor. Rumors. Something that's not rumors. How about CRISPR alert? I told you.
CRISPR of the week.
CRISPR of the week. What's the CRISPR story of the week? Well, some researchers at the Netherlands Cancer Institute in Amsterdam have been doing some CRISPR work that is not related to gene editing. So we like talking about CRISPR as a way to get into cells and into the chromosomes and edit them to actually insert DNA and make changes to DNA. But one other use of CRISPR, Cas9, is that it can be used to target specific things that we want to find in our genome. And so these researchers are using CRISPR to search for regulatory enhancer elements. Regulatory enhancer elements help to upregulate or to enhance the transcription of particular genes that they are related to. Usually they are not right next to. So if you're thinking of DNA as this linear series of letters, the genetic code, certain of those letters will be a gene. And then an enhancer element will usually be some distance away from that gene and not necessarily right next to it. It's just somewhere in the genome, but it has an effect. Its activation has an effect on the transcription of a gene. So what they published in Nature Biotechnology this past week is their work looking at how the certain enhancers regulate cancer. So they looked at two transcription factors, P53 and estrogen receptor alpha. And these get mutated and messed up really often. And when they get deregulated or messed up and because of mutations, then you have cancer. So P53 is normally works to lead to cell senescence or cell death when certain things take place within the cell. But if it's mutated, that doesn't happen, and the cell becomes cancerous and just continues to divide and divide and divide because P53 doesn't do its job. So they used knockout libraries. They had used libraries, these knockout libraries that other groups had created to find enhancing elements. And so they grabbed a whole bunch of these and basically connected it to the CRISPR-Cas9 system, and they threw them in to cells to see where these enhancers are that act on P53 and the estrogen receptor alpha element. And so they're just basically looking to find where the enhancers are in the genome. It's basically like a hide and go seek. These enhancers are in there. Where are they? How do we know exactly when they are? And how do we know when they're working and not working? What one of the researchers says is what we needed was a tool to pinpoint which enhancers are potentially important in cancer, because it's difficult to tell if a non-coding mutation in a tumor is causal for the tumor's growth or a consequence of it. And so these libraries are helping them do that. And so this is another reason not to be afraid of the CRISPR-Cas9 system.
Don't fear the CRISPR. No?
Yeah. Okay. I got it. I'll sing along. And then finally, for the intro part of the show, the Anthropocene. People have been debating whether or not the Anthropocene is really happening. Is human activity on Earth really affecting global climate change? Is it really affecting? Do we have the power to change the Earth? Yes, we do. We do. Each and every one of us, by our use of power, actually, has the power to change the Earth. And an international group of scientists has proposed this Anthropocene epoch, and they are saying that it is definitely
That's hilarious.
happening. Published in
That is
Science.
so hilarious.
Hilarious? What's hilarious?
No, not woman isn't a. I don't mean this. But calling it the Anthropocene, like, era. Like,
oh, that's been going on for a while. Yeah.
I know, but I love this idea. This is the first time hearing of it then. I love this idea.
Yeah, so their paper, The Anthropocene is functionally and stratigraphically distinct from the Holocene, published in Science this week. Very large group of researchers, 24 members. They are part of the Anthropocene Working Group, and they have evidence that humans have changed the Earth system sufficiently to produce a range of signals in sediment and ice. One of which is the ice age cycle that occurs, that we're probably not really going to see the ice age that was supposed to start because of all this heating of the atmosphere that we're doing. So there was going to be a new ice age. There should have been, but now there's probably not. Maybe sometime in the next 1,500 years, but we're pushing it off. Our activities have changed a global cycle, and this is just one of the pieces of evidence.
Maybe that's not a terrible thing.
Right.
Because it's better for us. But then on the other hand,
Earth not covered in ice. Right.
The entire planet. Whoops.
Yeah. So.
Yeah.
Anthropocene. I think it's appropriate for us to title this epoch after after humanity.
Absolutely.
That this is a result of our activities. So instead of being named after other events, historical events, we are a historical event on this planet. We're making changes. So researchers from Dr. Colin Waters of the British Geological Survey said humans have long affected the environment, but recently there's been a rapid global spread of novel materials, including aluminum, concrete, and plastics, which are leaving their mark in sediments. Fossil fuel combustion has dispersed fly ash particles worldwide, pretty well coincident with the peak distribution of the bomb spike of radionuclides generated by atmospheric testing of nuclear weapons.
Yeah,
All of this shows there's an underlying reality to this concept.
Yeah, and if you think about very far in the future, these very far off kind of archaeologists digging down into the sediment, right? And they're going to find, when we were around, this layer of, very vast, quick climate change, but they're also going to find all sorts of plastics. I always find that very funny, that there's definitely going to be this layer of plastics through the fossil layer. It's just like, oh, there's the humans.
Also,
Future.
predict that they'll be digging much faster than we could because they'll have 8 arms.
Right?
All right.
Octopuses.
Octopus, the octopuses
Oh, the
that rule the
octopus.
earth in the future.
Yeah.
Okay.
Wow. All right.
All right, everyone. This is This Week in Science. Justin, what you got?
I have scientists at the University of Texas at Austin have discovered the mechanism that may explain how the brain can recall nearly all of what happened on a recent afternoon or make a thorough plan to spend an upcoming afternoon in a fraction of the time that it would actually take to live out the experience. Yes, we have this fast forward button somewhere in our brain that allows us to think through all of the events forward and backwards as though they were all completely accessible, like a remote control. Go to this point, go to that point. And they say this previously unknown brain function has implications for research in schizophrenia and autism spectrum disorders, as well as Alzheimer's disease and other disorders as well. Disorders where real experiences and those that exist only in the mind can sort of become distorted or inseparable. The newly discovered mechanism compresses information needed for memory retrieval, imagination, or planning, and it codes it on the brainwave frequency that is separate from the one used to record real-time experiences, and is being discovered in the cover article in the January 20th print edition of the journal Neuron. So brain cells share different kinds of information with one another using a variety of different brain waves, sort of the way that you have a radio and can tune it into different frequencies and hear a different station. Your neurons are doing something equivalent. Laura Colgan, an assistant professor of neuroscience, and Chengguang Zheng, a postdoctoral researcher, and their colleagues found that one of these frequencies is allowing us to play back memories and envision future activities. The reason we're excited about it... Oh, go ahead.
I was just saying, that's interesting. So it's a frequency-based neural communication.
Yes, and so what they're saying is, as they'll go into this, is it's a longer wave that is moving at the same speed, so it's got more uppity downity things and has more information on it. Therefore, we can sort of go through a whole lot of bits of this idea of what happened yesterday, or sort of play a what might...
Oh, he's moving too much.
Playing a what might happen kind of game, I think is what he was saying.
Playing a what might happen kind of game.
Yes.
The reason that we're excited about it is we think this mechanism can help explain how you can imagine a sequence of events you're about to do in a time-compressed manner. You plan out those events and think about the sequences of actions you'll do, and all that happens on a faster time scale when you're imagining it than when you actually do those things. And what they're thinking is part of the disorders and things like schizophrenia may be that wave is getting confused with other waves, or that separating those waves, the fine-tuning of that dial to where you can have one wave alone being played versus another is part of the problem.
Yeah, so the mechanism within the nerves for differentiating between the information that's coming from different wave frequencies, from different communication channels, that it's not working.
Right. They're pointing out here fast gamma rhythms encode memories about things that are happening right now. They come rapidly, one after the other, as the brain processes high-resolution information in real time. They learned that slow gamma rhythms used to retrieve memories of the past as well as imagine the planned future events. Store more information on their longer waves, contributing to the fast-forwarding effect as the mind processes many data points with each wave. Yeah, it says mental compression turns out to be similar to what happens in a computer when you compress a file. Just like digital compression, when you replay a mental memory or imagine an upcoming sequence of events, these thoughts will have less of the rich detail found in the actual source material. Finding has implications, again, for a bevy of disorders.
Yeah, so it is interesting. So another issue that's brought up here is reliability of memory for things like we use eyewitness testimony for criminal proceedings, and we know that memory is fallible. And so maybe this is an aspect of that memory recall, like because of the way it's recalled through these gamma waves, it's like you said, a lower resolution. So the details are fuzzy. The gist, the big picture stuff is all there, but the details are not. And
And it's
so
sort of
you can remember it, but you don't necessarily remember what someone looked like exactly.
right. But it kind of also calls the question photographic memory. Like, what's taking place there? Is there compression? Are they able to retrieve all the data from the compression? Or are they actually thinking slowly, having to sort of relive the experience to see it? I've got to go back
I
and
still question photographic memory. I
so,
honestly don't
so
really think that photographic memory is as photographic as people say.
right. Right, but I mean, it wouldn't be a photograph, but it would be being able to completely recall. And I have met somebody who has this, and I think I've talked about this on the show before. He was somebody who, on the car lot, you have, a few hundred cars at a time on the lot. If you would look over a few cars and see the last 6 of the 17-digit VIN number, he could recall them. He could recall the stock number that was placed on it from a car he sold 6 months ago. You could literally point to 3 cars across the lot and have him tell you what those numbers were, and then be able to walk over there and verify it. I've met somebody who has that sort of recall. It's almost unbelievable while you're seeing it performed in front of you. You almost don't believe your own witnessing of seeing somebody do a photographic memory test. Also in the news, a new article finds that people living in countries where public service broadcasting is in play are better informed about government and politics, are more trusting of other people, and have more positive civic attitudes. They also have greater confidence in democratic institutions and are more likely to engage in democratic politics. The Political Quarterly article, which provides an overview of relevant research, also found that social trust is higher in countries with significant public service element in their media systems. Watching TV news is still apparently the main way in which most people keep up with current affairs, and public channels are more highly trusted than commercial channels for accuracy and reliability and the impartiality of their news coverage. Watching public service channels and listening to public radio stations are associated with a broad array of public attitudes and behavior that underpin democratic politics. Findings have important implications for policy discussions and future public service broadcasting in an increasingly commercialized world, says the report. Then not the report by me. Also, it by omission makes an interesting comment on corporate media. As you could easily say that the heavily corporate media leads to a lack of informed citizens who don't trust each other, have negative civic attitudes, who have no confidence in democratic institutions, and
I mean, that's putting words into the study's mouth.
That's not the way the logic works.
It's not the way the study works. I mean, it is the.
But hey, I wonder where we could
play that, but
see an example of that playing out in our
That would
society
be
today.
all you're saying is that this study begs that question, and further study should be done on that. What I'm also wondering about is
Blair.
that there's other countries that have many public broadcasting channels and other countries that only have 1 or 2. I think about, for example, in Great Britain, there are so many of the BBC channels. There's BBC at least 1 through 5, and I want to say there's more than that now. And so those are all public broadcasting. And in most U.S. cities, there's only 1, maybe 2. So I think that also is a potential to have a different kind of effect on that. Is if you're hearing it from multiple places, then that makes it even more reliable. But if you just have the one, hi guy, if you have the one public broadcasting channel, then it's very easy to point a finger at that and say, oh, that's liberal bias, which is something that we do here in the U.S. sometimes, calling the publicly funded broadcasting network liberal, which is
well,
also
when you say we though, like right? When you say we call it that, I always wonder who you were speaking of.
I'm saying people in the United States, in the public eye, like to say that. sometime.
I've not heard this.
Blair, you could make a fabulous politician.
Don't say that. What a terrible thing to say.
Ah.
Never been so insulted.
All right. Well, on that note, this publicly funded show is going to take a break. And when we return, we will have an interview with our guest, Dr. Will Dichtel, and Blair's Animal Corner, and more science news. Stay tuned for more This Week in Science. This Week in Science would like to say hello to all our friends in New York City. Thank you so much for having us at the Horse Trade STEM Fest 2016 this year. It was a fabulous trip to New York, and we had a lot of fun. If you want us to come to a science festival near you, let those science festival people know. Tell them to invite us. We go if we can. So we'd like to travel. TWIS wants to travel to more science festivals. Let's make this happen. TWIS also, we have merchandise that you may enjoy, so head on over to twis.org to check out our Zazzle store. We have a link. It says Zazzle in the main header bar on our website, and you just go there and click it, and when you get to our store, shirts and hats and mugs and keychains galore. So much stuff. You can proclaim your love of TWIS. You can give it as a gift, and at the same time, support this show. Also, TWIS is supported by listeners like you through donations. If you would like to donate to TWIS, you can do so in a couple of ways. We have PayPal buttons all over our website, twis.org, and additionally, we have a Patreon account. It's Patreon, patreon.com/thisweekinscience. Patreon allows you to pledge on an ongoing basis from month to month, episode to episode, and manages it in a different way from PayPal. So it's just a different way to do things. If you are interested in supporting us with a donation, whatever amount you're able to give, it doesn't matter. $5, $2, $1, 50 cents, it all helps. Any amount goes toward keeping this show running, paying for contractors, bandwidth we need to just make the show happen, equipment. It all really helps keep this show going. If you cannot afford a donation, we can always use help from everyone in the audience just in telling your friends about TWIS. Spread the word of TWIS. Try and get more people to listen so that we can grow our audience, because that will grow everything for everyone. It'll make it possible for us to do more things when we have more people watching. Also, if you listen to iTunes, give us a review on iTunes. Thumbs up, positive reviews that were really helpful to you. That will help us out as well. We thank you for your support. We really could not do this without you.
Explain the things you heard with more than intuition.
And we're back with more This Week in Science.
And we are joined by our special guest, Dr. William Dichtel. He is an associate professor in the Department of Chemistry and Chemical Biology at Cornell University. He is also in sabbatical at UC Berkeley currently, so we are speaking to him tonight as he sits in his new office in Berkeley, California. He had got his Bachelor of Science from MIT, got his PhD from UC Berkeley, so kind of got an idea maybe why he's going back there.
Good homecoming.
Yeah, he's also worked at UCLA and Caltech, and is working on, and he's also a MacArthur Scholar, MacArthur Fellowship, as we all know. is the Genius Grant. How does it feel to be named a genius?
You know, I got to say, it was a pretty awesome week. I'm still kind of getting over it, but pretty sweet. Pretty sweet.
But it still sounds like it doesn't help you keep down a job. You've been a lot of places.
Well, you know, you go do things in science, you got to travel. I mean, you know, you got to kind of bounce around from place to place, and eventually they'll give you a permanent job.
It sounds like you've landed in a pretty nice place currently. Can you tell us a little bit about your overarching research goals, like what you're working on generally?
Sure. So I'm an organic chemist, and I study organic chemistry, polymer chemistry, especially new materials. And so my group starts from thinking about new chemistry and new ways to make bonds and things that people have never done before. And then we usually use those to make some kind of new material, you know, like a plastic, you know, we're anthropomorphizing the planet with them. But our plastics tend to have a little bit more function than a milk jug. We are working on things for energy storage. We've made some materials that are interesting for sensing. The paper that came out today that I think we're going to talk about is about water purification. And so we try to go all the way from new chemistry out to how it could have an impact on other people's lives.
So when we met in person, you had just given a talk at the American Chemical Society meeting on an idea in your research that just really struck me as I don't know, an kind of artistic and creative way of thinking about chemicals. Normally we think about chemicals as the atoms and the bonds between them, so the actual the structure, the thing itself. But in your talk, you stressed the importance of thinking about the empty space.
That's right. And that's a big part of our work, is that if you can design the way molecules will come together, or how they can pack, or especially if they can pack inefficiently, you can create voids in the material that are kind of similar size as the molecular building blocks themselves. And when you do that, first you're kind of controlling space down at a very small scale, where a material might interact with molecules differently depending on the size and shape of those voids. You also impart really high surface area when you do that, and so a lot of the applications we're interested in take advantage of that high surface area.
And does this have anything to do with your paper that was just published in Nature?
Absolutely, and in fact that's the key innovation to it. Basically what we've done is we've taken a molecule called cyclodextrin, and cyclodextrin is in your day-to-day life whether you know it or not. The most kind of famous example is that derivatives of it are used in Febreze, and it's the active ingredient that makes things less smelly. And
I always wonder, every time I spray that stuff in the air, I'm like, where does the smell go?
Well, you're about to find out, because it works very much the same way as this material for water purification. So cyclodextrin is a ring of sugar. Specifically, it's 7 sugars in a ring, and so it's a molecule kind of shaped like a cup. And just by virtue of how those sugars are organized, it turns out that the inside of the cup is very hydrophobic, or very oily, and yet all of the parts of the sugar that make it water soluble are pointing to the outside. So cyclodextrin, when it's unmodified, is very soluble in water, yet it has this pocket that greasy stuff likes to stick to. And so that's that's how Febreze works, is that most of the things that are smelly are either oily, or at least part of the molecule is oily enough to stick in there. And so all it's doing is sequestering it so that it doesn't reach your nose. It doesn't actually make anything cleaner, it just makes it less smelly. It
puts it in a pocket.
Exactly.
It takes the smell and sticks it in a pocket and then closes the zipper.
Exactly. That So it's not cleaner, for you college students out there who are using this stuff. It's just less offensive. So that's the first step, and so the ability of cyclodextrin to do this has been known for decades. I mean, there are thousands of papers that use cyclodextrin for various things. It's also used in the pharmaceutical industry. Sometimes you'll dock a pharmaceutical agent in there, and then the cyclodextrin will help it be more soluble in your bloodstream. Just lots and lots of different uses of this compound. And what we've done is that we've taken cyclodextrin and we've linked a bunch of cyclodextrins together into kind of an extended polymer network. And so we basically we take cyclodextrin, we react it with something else that can react with 2 or more cyclodextrins at once, and then that just proliferates infinitely, and so we end up with this powder that's a solid that just is made up of cyclodextrin plus this crosslinker. And so after that, it's no longer soluble in water. Then you've got a powder that you can flow water over it or through it or past it, and the cyclodextrins will all stay put because they're locked into this kind of infinite structure. And so, but there's still these cups, and they still have these binding sites for, now in this case, pollutants. So when you flow polluted water by it, a lot of these things that you don't want in your water will stick inside the cups. And so that's, in a nutshell, how this material works. Now, you asked about high surface area. And so the idea here is that even that part of the idea has been around for a long period of time. People have tried to make polymers containing cyclodextrin for decades, and all of them had very low surface areas. And so they worked, but they weren't the best thing out there. The best thing out there for decades has been a material called activated carbon. And so if you've ever cracked open a Brita filter and poured it out, part of the black stuff that's in there is activated carbon, and it's a very straightforward kind of material. It doesn't have a very well-defined structure, but it's super high surface area, and it will also bind these pollutants. And so it's just turned out that the very high surface area of the activated carbon has caused that material to outperform previous cyclodextrin materials. And so what we did is that we added the high surface area to the cyclodextrin material, and you kind of get the best of both worlds, and you get a material that strips pollutants out super, super fast, and it's got a lot of other positive attributes as well, including being able to be regenerated and reused over and over again.
Yeah, and that's something with the activated carbon. I mean, we know anyone who does use a Brita filter knows that once it's done, you can't rinse it out again. You just throw it away.
Yeah,
you're done.
You chuck it. Yeah, and so we found that with our material, you can just rinse it at room temperature with methanol or a range of other things that are relatively inexpensive and benign, and all the pollutants will just instantly come out of them, and then you've got your empty cups again. And so then you can just take your material and put it right back in line in the water and start cleaning it again.
That's great.
Okay, it sounds like an amazing, it just sounds like a miracle material.
Well,
what are the downsides?
Well, I mean, so the downsides are that activated carbon is made on the, kiloton scale industrially, and we need to prove that we can manufacture this material and that we can manufacture it at a cost where the overall life cycle use of it is economically competitive with activated carbon. So what we've shown in this paper is that the performance of this material is superior. There's really no debating that in terms of what's there for everyone to read. But what we need to do now is that we need to go from an academic group where we make this material a few grams at a time, and we need to find a way to manufacture it. And so that's the next step for this particular, that exact material that's in that Nature paper, is that we are looking into that. That's not that is not best done in an academic group. I'm not a chemical engineer. I'm not a, I don't develop processes on that kind of scale. That's not what my students think about on a day-to-day basis. But it is something that I think is important, and it's something that we're looking into now, potentially starting a company or looking at other ways to get this out into the world.
And I'm guessing, cyclodextrin, since it is in such common use, that that material itself, or the production of that of cyclodextrin on its own, is not the problem. It'll be the process of adding your linkages.
Exactly. Yeah. So cyclodextrin is the manufacture of that is very well worked out. It's actually made directly from cornstarch. Various large companies make this on huge scale, where they've evolved an enzyme that can just chop up cornstarch directly and make cyclodextrin perfectly. And so that's a very mature process, and it basically makes cyclodextrin available for $1 a kilo or less in some cases. So that's great. The crosslinker likewise is a commercially available compound. It's not generally used on the same scale as cyclodextrin, but also I don't really view that as a bottleneck. But the bottleneck is the actual polymerization that we do, and we're reporting for the first time today, is that we're going to need to take that. The chemical engineers are going to have to get a hold of this stuff. They're going to have to, do a lot of things that are beyond my knowledge of how to do this on, in these huge steel reactors instead of in little tiny glass flasks the way my group does. But we'll do that, and if we're able to do it, I think that. It's very exciting to think about that from the perspective of where we started with this project, and to think that this material has properties that justify that kind of investment is super exciting to us.
Now, in terms of, it's very exciting, but in terms of the how well this substance works on various substances. Does it have a higher proclivity for some substances and not for others, or what have you tested it on specifically?
Yeah, so we are reporting the removal of a lot of different organic micropollutants in this paper, and organic micropollutants it's a catch-all term for pharmaceuticals, for pesticides, for components of personal care products that are all starting to get through our typical wastewater treatment that is done now. And so this has been a problem that is starting to attract more and more attention. It's likely to start attracting even regulatory issues down the road. There are certain countries are actually even well ahead of the U.S. in looking at this and trying to remove them. And so we've done a small subset of those in this paper, including a complex mixture of them down at concentrations that are relevant for wastewater treatment. But we certainly haven't done them all. And so my co-author on the paper, Damien Helbling, is a faculty member in Cornell's Department of Environmental Engineering, and this is what he does for a living. He studies organic micropollutants. And so since we have submitted this paper, we have continued to study the performance of this material, and there's just kind of a profile for what it's good for. Part of the good aspect of this is that cyclodextrin has been so extensively studied that we can take a paper that was published 20 years ago about just some random compound that someone bound up with cyclodextrin, and we have a pretty good idea that our material works similarly. But it's not exactly the same. So now we're developing a predictive model based on studying 60 or 70 compounds instead of a mixture of 9, where once you study that many, you can start generalizing, including doing some pretty sophisticated math on this. There's all sorts of parameters used to describe molecules, and so you can run regressions on these things to figure out, okay, which parameters are the most important and are predictive for whether a compound will be removed by our material. And so there is a slightly different selectivity profile for our material as compared to activated carbon. So in some cases, they're going to be complementary to each other. In some cases, you might consider a process where our material is used to catch the stuff that activated carbon cannot catch. Or in some cases, you might just find our material to be just overall superior, just depending on what exactly you're trying to remove and what concentrations and so on and so forth.
Really well. I was very much considering this only for the water purification aspect of drinking water and using water. But yeah, if you can capture all the pharmaceuticals that are getting back into the waterways, is there any indication that this is something that would work on microplastics?
Well, I think microplastics are probably a little too big. I think they're, so this is really a molecular interaction. So, some drug molecule that's a small molecule fits nicely into this cup, and so therefore it's going to work well. I am not an expert on microplastics, but I get the sense that that's kind of an order of magnitude or more bigger than these interactions, and so I think that will still require pretty sophisticated filtration down, that where that filtration would be based only on particle size, and getting a particle filter that is that stringent down at that size scale, yet doesn't introduce a ton of back pressure when you're trying to push water through such a tiny hole. That's a whole nother challenge, but I don't think that it's addressed by our work here.
In the chat room, Hot Rod is asking, will it filter hormones from wastewater?
Yeah. So a lot of these hormones would be in these classes of so-called micropollutants, and so one compound in particular that we study in the paper is ethynyl estradiol, which is a major component of very commonly used contraceptives, and so that, not surprisingly, is something that is around ubiquitously in our modern lives and is getting into our water, and that's a big deal because these kinds of hormones, including ethynyl estradiol, they've been shown to affect fish down at very, very low concentrations. And so we immediately started looking at these things when we realized what we had on our hands.
What led to the exploration of this particular material? How did you end up in this?
Yeah. Well, it in kind of a roundabout way, as is a lot of scientific projects. I was really lucky to get involved in a center funded by the National Science Foundation called the Center for Sustainable Polymers. And so my group, before our involvement in the center, had already developed expertise in porous polymers, but most of them were derived from compounds that were came from petroleum. And the purpose of the center, bigger than our own work, is to try to develop plastics from renewable sources, non-petroleum sources, that might have very high performance in various applications. And so I got invited to participate in the center despite not having a lot of experience in that area. And so we started thinking, okay, what kind of things would be really, really good to make a porous polymer out of? And cyclodextrin came to mind, not at first for water purification, but just because of its shape. You asked me earlier about this idea of, okay, how do you get porosity into a material? How do you get a high surface area material? And the analogy that I used in the talk that you mentioned is that one way is to use molecules that don't pack well together. And so I said it's kind of like playing Tetris on too high a difficulty level. You have these molecules come together, they don't fit quite right, and you get voids, just like when you're really bad at that game. And so
cyclodextrin,
yeah, well, me too. And so cyclodextrin has a shape, right? It's got, I said it's got this cup shape, and so that we said, well, maybe that won't pack so well together. And so the key to doing it was to take cyclodextrin, and previous people, I said, had tried to cross-link it, but they always cross-linked it with things that were kind of floppy. And so even though the cyclodextrin had a shape, kind of the links between them were floppy, so you still gave the material an ability to kind of pack together. But we used an extremely rigid molecule in between the cyclodextrins, and so the rigidity of both of them together combined to give us this high surface area material that had such better performance.
It's really neat. Like I just love like the thought process that gets involved in creating something where you're like, well, we have this problem. Let's approach this problem. We've got this one thing, and then let's try this other thing. Let's put these things together. And
that's exactly it. And you know, I work with a really outstanding team of students and postdoctoral researchers, and you know they're constantly talking among each other and kind of making little hybrids of things, and exactly we kind of lead off into pathways that we didn't really expect to go down.
It's wonderful. The exploratory nature of science. It's just fantastic. Well, Blair, Justin, did you guys have any more questions?
Yeah, thank you for your time, but this is, I mean, as many stories as we've reported on the effects of hormones and pharmaceuticals and waterways and the downstream effects on wildlife, to have something on the horizon, and I doubt it will take you too long to find a couple of partners who have some real interest in creating a manufacturing process for you. It seems like the heavy lifting, honestly, has been done.
Yeah. And especially with all of these studies that we're reporting on with the negative effects of the hormones or the pharmaceuticals in the water, not only on the natural ecosystems but on humans as well. It's just a hop, skip, and a jump away.
It is, but I think your point was right, though. It requires a regulatory change, probably, to create the financing for it, because there's not a lot of salmon with the bucks to back this. So.
Yeah, well, I think that there are a lot of aspects of water purification that are relevant industrially, and I think that the key to really being successful with this on that scale is to identify niche applications where this thing is well suited for folks who have the dollars to pay more of a high value added for a really superior technology, and then that likely will get us to the point where naturally we're scaling up, and you know the wastewater treatment market is so big and likely pretty conservative also. So right. I think that there's going to be a process where it's not going to be day one, here we are, here's the paper, you know, a month later we have a manufacturing process. It still is slow, and there are going to be little bumps along the way, and you know there could be really unanticipated things that come up also. But it's really exciting to have something that's worth the investment and worth us really thinking about. And you know we certainly are going to push this as far as we can, because the chance to have that kind of impact with the material that we made for the first time is really gratifying. So it's worth it both economically, but it's also worth it emotionally for us to continue pursuing this.
Absolutely. If you can have an impact to help create more pure water, drinkable water, reusable water for people on the planet, it's a huge impact.
Yeah.
It's huge. Thank you so much for joining us tonight, Will. It's been wonderful hearing about your research. Where can people find you online? Do you have any social media accounts?
Yeah. So I'm on Twitter. It's @Dichtel, which is my last name, Dichtel. That would be the primary medium that I use for kind of sciencey related stuff. So check me out there. And I'm at Cornell for folks who are out there who are looking to go into chemistry. I'm there, and then my group will be moving later this summer to Northwestern University, and so. Nice. Look for us there later this year.
Fantastic. Well, good luck in your efforts moving forward with this research and the other work that you are endeavoring on. And thank you.
Thanks so much, Kiki. It's been a pleasure.
Have a great evening. Thank you.
All right.
All right, everybody. Let's get back to some science news. I think This is This Week in Science, and it is about time for Blair's Animal Corner.
She loves our creatures, crabapes, all. 5 peg, millipede, no pet animals. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels.
What you got, Blair?
Oh my gosh, you guys, I have some really exciting animal news tonight. So to start with, it's exciting. So to start with, I have some really intense human emotions found in some animals that are not so human. Shocking, I know. We don't talk about this, like, ever. But when you see somebody, I don't know, let's say Donald Trump, and you see that someone like Donald Trump has so much, and maybe you're a person who doesn't have a whole lot, how does that make you feel? Does it feel fair?
I don't know. I don't really think about, I try not to think about what Donald Trump has and what I don't have all that often.
Well, in general, sometimes some people like to think it's a little unfair.
That some people have more, and maybe Trump was born into his money and he didn't work for it. Darn it.
Or that nobody should need that much money, for example. Okay. And that there are people that need things, right? Well, we have a word for that. And that's called spite. Not liking that someone else has when you do not would be spite. And it turns out that monkeys can feel spite. So before, we've done studies with chimps where chimps will, if one chimp steals food from another chimp, then the chimp that stole will get punished by the other chimps when those chimps have the option to punish them. Usually it's with some sort of mechanism where they can pull on a rope that'll collapse a table and make their food fall down a hole onto the floor, what have you. Well, in a recent study from Yale, capuchin monkeys decided to yank on a rope to collapse a table holding a partner monkey's food only because they had more food. Yeah.
You've got more than me. I'm just going to take it away. I'm going to knock your table down.
Yeah. So this is very interesting because this is a really intricate emotion and kind of cause and effect that we wouldn't expect to see in non-human animals. But this comes down to something that we call social norms, right? So the social norm is you get this much food, and if you're violating that social norm, then you must be punished, which we can extrapolate to other things, that people are punished for violating social norms all the time. You think about something that is good to turn into a social norm. Let's talk about reusable bags. If you show up and you buy a plastic bag, some people might look at you and go, "Where's your canvas bag?" You're violating a social norm. You're being punished for violating the social norm. So there's other situations where this happens. But ultimately, this has not been seen before in relation to spite.
Seriously.
Yeah, so it's pretty intense.
I don't know how I feel about this one. I mean, this is I mean, it just takes back the anger, this basal human emotion, and the capuchin monkeys they're not super closely related to us. I mean, yes, they're primates.
They're very monkeyish.
They're very monkey. But and so for something that we split off from, a long, long, long time ago, distantly related to, that we would share something related to jealousy and acting out of jealousy, spite. That is it's interesting. And not necessarily just to steal from the other individual, but just to make it so
you can't
you
have.
Yeah, you can't have
it. If I can't have it, you can't have it. Yeah.
Fascinating.
So it might be a more basal thing than we previously thought.
Yeah.
So that's the monkeys with spite. Now on to the spectacles. This is perhaps
the spectacles.
the cutest story of the week.
Yep.
So scientists in the UK at Newcastle University wanted to figure out how invertebrates see. They wanted to see particularly how invertebrates see in 3 dimensions. And so they looked at praying mantises, a species of invertebrate that use stereopsis for hunting. So it's
like
3D.
us, stereo vision.
Exactly, binocular vision, right? And so they use that to gauge depth, and they hunt using that. And there have been other situations where we've tried to test this on insects, and particularly mantises, and they were trying to use prisms, they used occluders, so that was all kind of related, but they weren't able to directly prove how this worked. So what did this team from the UK do? They made 3D glasses for the praying mantis.
And they look pretty awesome. I think I really do want a pair of these. I mean, they're these are just some cool lenses.
They're rad. They're so rad. So
I honestly don't. I mean, did they take these 2 pieces of glass and simply glue them to the middle of the praying mantis head?
Yes, that's beeswax in the middle. Yep.
Okay. It's amazing. I was trying to figure out how they stuck it on there.
Well, they put little ear pieces on.
No.
No,
mantises don't have ears.
They use beeswax. So what's interesting though is that our 3D glasses are what colors?
Red and green. Red and blue. Red and green?
Blue. Red and blue.
Okay.
But with these guys, it turns out they don't see red very well. So they used green and blue. And they had a bug on a screen moving around in 2D, and the mantises didn't do anything. And then they had the bugs moving around in 3D with the green and the blue. Sorry, I'm getting my color names mixed up. Wonder why. So
A little bit colorblind. There you go.
So yeah, 3D's never worked great on me. I wonder what the science behind that is. Anyway, tangent. So they had the bugs moving around in 3D with the green and the blue, and the mantises kept striking out at them. And Kiki's showing a video of it right now, and it's kind of hilarious. They're going, gimme, gimme that. And so they found out that they really do use 3D vision in what we traditionally call 3D vision to hunt. And this definitely confirms an idea that we had, but we weren't sure before. Now we definitely know how this works in mantises. So this opens up a whole new kind of realm of study now that we understand how their 3D vision works. But 3D glasses for mantises for science. Yeah.
Who knew that science would lead to glasses for praying mantises?
Oh, I did. No, I didn't. But I'm not surprised at all. And then my last story, since we're getting towards the end of the show anyway, is naturally about sperm. And if you were trying to breed a specific type of animal, if you're doing selective breeding and you wanted particularly to have male or females come out of an insemination, usually you would do cytometric sorting. So that's basically just a centrifuge. And because
it's a cell sorter. It's
a
cell sorting centrifuge.
Yes, and because male sperm are smaller than female sperm because they're missing that little tail that makes it an X versus a Y. They're very different sizes and densities, and they kind of sort out. And then you're able to just kind of scoop and go for what will mostly turn out to be the gender that you are hoping for. But a new method from the Texas Tech University Health Sciences Center, has found a way to chemically attract the sperm of the gender you're looking for, as high as 72% success rate, which is pretty good. So it's cheaper, it's easier, it's faster.
It's probably more accurate than the rhythm method.
More, well, definitely. Or eating lemons or whatever you're supposed to do. But so right now they're saying that this is
eating
going
lemons
to be...
a thing?
I think so. I think that's an old wives' tale, but I don't remember which one that is. But regardless, this is something that they're saying is going to be used for livestock, for making lab animals, for selective breeding. But really, I think we know what this is going to get used for. Designer babies.
Designer
I like to talk about them a lot.
Right
Designer
along with the CRISPR.
Yes,
CRISPR
I do.
And
I do
sperm
feel like
selection.
I should have
babies.
put that. I
There we
should have
go.
put that in my predictions for 2016. But I feel like it might still be a couple years out. But I feel like we're pretty close to just filling out a questionnaire.
Do you want a
saying, "I want
boy
one
or
of
a girl?
these. What color eyes? What color hair?
I would say the highest and
Smart
best use.
or athletic?
I would say the highest and best use of this might be in breeding lab mice.
Yeah, well, that would be helpful. Also, when you're trying to breed meat, you might particularly want females. If you're at a dairy farm, you might particularly want males. If your job is inseminating cattle.
Yeah.
These are
Interesting
all
useful
uses.
things. Very useful.
Yep.
Oh, the future is bright. And, a cool finding this week that I thought was really neat. The BBC has reported on a canyon on Earth larger than the Grand Canyon.
Huh?
A massive canyon.
Is it
Underwater.
It's underwater.
No, it's
not underwater.
It's
under
in
ice.
Antarctica. It's under
That is
ice.
underwater. That's underwater.
Well,
It
it's right. It's
under
underwater,
ice.
frozen water. Yes, it's 2 times the length of the Grand Canyon, and researchers using satellite images have been looking at an area called the Princess Elizabeth region, which has not really been well explored historically. So they're now using satellite images and backing up their claim with radar sounding that has mapped the rock below the ice, and they have found signatures of a 600-mile-long series of canyons that are connected to a lake, a subglacial lake under the ice. So this is an interesting finding. We'll see how the ice responds to, the Anthropocene. But
Yeah, so once it's all melted, that'll be another
it'll
canyon
be
you can go visit.
another wonder of the world. They'll put, observation decks and stuff, and there might be
Identity
donkey rides
4.
to
I
the
like
bottom.
it.
Oh, and
That's right.
kayak.
And
Grander
kayak.
canyon.
Kayak.
Nice.
That's what I'm wondering. Is it if it's bigger than the Grand Canyon, are we going to call it the Grander Canyon?
I
What do we
like it.
call it?
Identity 4.
Grandiose
Right.
canyon.
The Grandioso Canyon.
Grandioso.
The really big canyon.
There you go. That one.
That one.
That's humongous.
And also, my last story for tonight related to the flu. It is the winter, so people like to talk about the flu. And then, in couples, there's always the ha ha ha, my husband or my male partner got the flu. Man, he's such a wimp. Why is he? He just can't take it. What's going on? Well, it turns out that, according to recent research published through the American Physiological Society, estrogen protects women from the flu. Like estrogen.
We finally got one, you guys.
Estrogen protects us. It is protecting.
Finally, the women have it better off for something.
Yeah, so the researchers exposed cell cultures to the influenza A virus, and they got these cells are nasal cells from men and from women, and they also exposed these cultures to estrogen, bisphenol A, which is an environmental estrogen as well, and a selective estrogen receptor modulator, or SERM, and these are things that act like estrogen and are often used for hormone therapy. Researchers found that estrogen and raloxifene, one of the SERM compounds they looked at, and bisphenol A all reduced flu virus replication in nasal cells from women. but not from men. And they do this because we have lots of estrogen receptor betas. These antiviral effects take place because of the receptors, their protein structures, and the molecules bind with them and induce the cells to respond. So we have evidence of how estrogen protects us. And so the question, though, is we don't understand now what this means for women who are going through an estrogen cycle. So if you're on the pill,
That's
you
what I was
probably
gonna
have
ask, yeah.
consistent, if you're on a pill or some hormonal therapy, you have a consistent level of estrogenic protection from the flu. It'll protect you a little bit more. But what about when you're cycling? The question is, during some periods of the month when your estrogen levels are low, are you less protected than other times of the month? And this is a question that still needs to be answered. Don't know.
Right.
But
And when women go into menopause, are they then less protected?
right. Yes. These are great questions. Yeah. But for those of us who are, I don't know, when you have the estrogen, be happy. You'll be less likely to get the flu or less likely to feel as bad if you get the flu as, say, your male partner or male friends.
Estrogen.
Estrogen, yes. So, guys, I just want to apologize. You're not wimps.
Well,
You just don't have enough estrogen. It's okay. Don't feel bad.
be more like a woman.
Of,
That's what we're trying to tell you.
Instead of getting a flu shot, women should rub their hands on store receipts to get that little bisphenol
A, right?
into the system. Right?
No thanks. I'll pass.
Better
I
than
will
zinc.
pass. I'll pass.
Yeah, is that why I'm not sick and Justin's sick right now?
Probably.
We were on the same subway trains.
It was your estrogen, Blair. Your estrogen was saying.
She's finally doing something for me. I'm really excited.
Do we have any more stories?
I'm all done.
I think that's it.
All right, everyone. I want to give some shout outs to our Patreon sponsors. Thank you very much to Kevin Parachan, John Ratnaswamy, Steve DeBell, Jason Schneiderman, sorry about that, Rudy Garcia, Gerald Sorrells, Greg Guthman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Patrick Cohn, Richard Onimus, KDWB, Byron Lee, EO, Bob Calder, Jared Lysette, Ulysses Adkins, Brian Condren, Jake Jones, Trainer 84, Kati, Edvardus Rimkiss, Brian Hedrick, Cassie Lester, Sarah Chavez, Steven Stroyek, Layla, Shannon Tara Ginsburg, Marshall Clark, Charlene Davidson Henry, Don Kamarechka, Larry Garcia, Randy Mazuka, Ed Dyer, Tony Steele, Dave Friedel, Craig Landon, Daryl Lambert, Robert Aston, Sylvan Westby, Artyom, Michael Perez, Shuwata, Stephen B., Dave Wilkinson, Steve Mashinsky, Rodney Lewis, Braxton Howard, Phil Nadeau, Rick Ramus, Salgood Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stefan Insom, Michael George, Russell Jensen, Mountain Sloth, Jim Drapeau, Tara Payne, Alex Wilson, John H. Maloney, Jason Olds, James Noah Wiles, Paul West, Alec Doty, Aluma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, Paul Stanton, Scott Lajewski, David Simmerly, Tyler Harrison, Ben Rothig, Columbo Ahmed, Gary Swinsberg. Thank you so much for your support. Thanks for your support on Patreon. And if you're interested in supporting us, you can find information at patreon.com/thisweekinscience. And remember that you can help us out simply by telling your friends about TWIS. On next week's show, we'll be back with more science news, broadcasting live online 8 p.m. Pacific time, Wednesday night, twis.org/live, where you can watch and join our chat room. Don't worry if you can't make it, though. You can find our past episodes at YouTube.com. Well, no, twis.org/YouTube. That's a good one. Twis.org/YouTube or twis.org.
Thank you again for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have a mobile device, you can look for TWIS Forward Droid in the Android Marketplace, or simply This Week in Science in anything Apple Marketplacey, including the new Apple TV thing that's I'm hearing about.
For more information on anything you've heard here today, show notes will be available on our website. That's www.twis.org, where you can also make comments and start conversations with the host as well as other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Just be sure to put twist, TWIS, somewhere in your subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TwistScience, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from today's show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
Have I ever showed you the coolest blanket I own that my grandmother got or gave me?
No, that's a blanket?
It's a blanket my grandmother made
That's
me.
pretty
I'm so jealous.
I think I should probably make an announcement
She made it. It's
on the show right now.
what?
Oh, did you win the Powerball?
I did.
Did you
No,
win
you-
Powerball? Are you
I
going to save
did.
us?
I did, and I don't normally play, which is what's amazing. It's just all the... There's a 7-Eleven 3 blocks from my house, and all I could think of, if I wake up tomorrow and they're like, well, the winning number was purchased at a 7-Eleven 3
Right.
blocks from Justin's house, and he didn't even get into that pool of people who the machine selected to win. I would have felt really miserable. So I went down there. Like I said, I don't play, so I asked for 10 picks.
Right.
And thinking I was going to be charged $10. Apparently,
Right.
this is a $2 deal.
Oh, so you spent 20
So I
large.
spent $20. I didn't really, but it looks like I may have gotten 10% of my money back because I have one of the winning extra number thingies. I got the.
Oh, you have a
number.
Powerball number.
I have a Powerball number that hit.
So
What does that
you make
mean?
$2?
I think I get my
$2?
$2 back. I think that's what
I
happened.
got $2.
But I'm gonna come into work tomorrow like, all right, y'all, boom, winning ticket, I'm out.
I've won like $5 on a lottery ticket before, and I never cashed it in. It was a
Like-
scratcher. It was like $5, and I was like, I'll do that later.
Yeah, it's like $5. I wonder how much money goes completely unclaimed because
A lot.
it's stuff like that.
Well, except I wonder.
And then the state
does
is
it
like,
go back
"Oops,
to
wanna
the
keep
schools? Does it go back to schools or?
What's the statute
No,
of
not really.
limitations on the
Not
money
really.
that's
So-
out there? No.
Here's the fallacy of the lottery.
I don't really think any of the money goes to the lottery.
It's
I mean,
supposed
goes
to go
the
to
schools.
schools.
No. Here's the problem with it. And although this time
They're liars.
a significant chunk will probably go to the schools because it got so big.
Right.
But typically what the pattern has been as lotteries have grown, states have cut back on what they spend on schools out of taxes and rely on the lottery to facilitate the funds for it. So instead of adding an extra amount on top of what schools get from taxes, what's been taking place is tax money has been diverted away from education so that it's about the same as it would have been anyway. Does that make sense? Is that I speak this properly? So we're not really increasing money spent on schools by having
Why?
a lottery. We're decreasing the amount of taxes that get spent.
Oh.
They just cut the budgets as the lotto money comes in.
So basically, it's a tax. We are paying a tax.
Well,
We are, because they don't give us the money back. I mean, it's not like
no, it just gets diverted to other things, which isn't necessarily a bad thing. It's
Right.
not necessarily a bad thing. But the idea
But our
that
education could
but
use
the,
more.
The idea that
Yeah.
going to schools, that money is locked into going to schools, but your tax money isn't locked at a percentage budget.
So what if we did
anything.
all taxes like the lottery? So if we did all taxes like the lottery, you get a certain number of tickets for whatever you paid into taxes this year, and somebody wins a giant refund.
Mhm.
People might gripe less about taxes.
No, everybody would gripe because they would win like they win the lottery. They would get their taxes back like they get the lottery back.
yeah. Let's see. So let's see. What does this say? Roughly half of the money that has been made from Powerball ticket sales since it was started has gone to the winners themselves. The rest, all profits from the games are kept by the state that sells the ticket. So it gets divvied up by state.
California!
States must pay for expenses before counting the funds as profit, and then that's advertising, salaries, vendor fees, accounting, government securities to fund annuitized prizes, and then you get the profits, and then every state is different. So, or let's see, Rhode Island reported their lotto program added just 11 cents per dollar of ticket sales to the annual budget. Oregon generated 50 cents in profits for each dollar of ticket sales in 2011. And then it's up to the state to decide what they'll do with the money. So a common benefactor is education.
Right. So this
All
is how it
profits
got-
all profits
in
for Virginia
California-
go to education.
Right. In California, it got sold that it was going to be education dollars.
Yeah.
But again, what happened was they reduced the amount of our tax dollars that went to education as these funds came in.
Some
Interestingly,
states
though,
count lottery profits as general revenue or subsidized tax cuts promised by politicians, making them a sort of hidden voluntary tax.
yeah, because but those tax cuts
Interesting.
in those states tend to go to who? The wealthiest amongst them in the state. So it is another tax on the poor in that specific scenario.
Wiz Mike is wondering if TWIS got all drunk science in New York.
Yeah, and I said, unfortunately, no. But we should have done a short at the bar after, definitely next year.
Oh,
Right.
I'm glad there were no cameras rolling. First
Did you go karaoke?
We did.
We did that, but before that, right before that, at the after party at the next table.
Justin befriended some deviants.
No, I thought this was. I think I made my first night in New York. I think I may have pimped.
Yeah, how they were going to start a band and steal a tour bus and travel across the country.
Justin thought he was being an adorable matchmaker, that there were these two cute kids that had met each other at a bar, and he was just trying to help them get together.
And it became a little bit clear that one of them might have been a prostitute. Very likely. Wasn't obvious to me, but should have been obvious to me later, because at first I thought they all knew each other, and then later I realized they didn't.
Oh, Justin in the big city, he's just not used to it.
But what was really weird was I think technically it wasn't that I pimped her, like I think that's what the pimp's normal role is. I think I pimped the John. I think I was like a prostitute wingman and encouraging them to go out and spend all of his money for the rest of the evening.
Oh, no.
And it wasn't until I was walking away from the whole event and I'm like,
what just happened?
Oh, that's what just happened. My gosh, I now. Oh, yes.
Oh, good gracious.
I'm not sure if that's a crime, but as an occupation, I feel like I'm built for it. Like, I really do feel like I could be really good at this.
Matchmaking.
Yeah, that's what it is. I'm a matchmaker.
Matchmaker.
The yenta. The
not
TWIS
a
yenta.
monsieur? What's the opposite of madame? Monsieur?
Monsieur.
Monsieur. Just on Raphael Jackson, I am the monsieur. Yeah, it was. Yes, Janescu, I have one. I'm still never editing because I just need to wait till my youngest child is in school, like during the day, and I can have an hour of my life to myself. This is all I need. I just need time.
You guys, this is the piece of my microphone that snapped off. See, look at this welded metal. I just.
Time writing.
I just hulked it off. I was just like,
what are you holding
that's
up?
a piece of my microphone stand. That I was just like,
oh yeah,
it's not tight enough, and it just went.
No. That's exactly what happened to mine. That's exactly. It. This is why I don't use it anymore. And I don't know where the part is. But that's exactly.
But my steering wheel's broken, you guys. I'm really bummed. I thought I was gonna have to hold my microphone the whole show today, but luckily, my duct tape, my tinfoil and super glue worked. It held through the show.
So glad. So John R. Sports on Twitter, he found this somewhere, and I don't know how he found it, but it's a spoof on Don't Fear the Reaper. You know how you were singing Don't Fear the CRISPR?
Yes.
All our genes have expressed here, but now they've left. Seasons don't fear the CRISPR, nor do the wind, the sun, or the rain. We can be like they are. Come on, baby, don't fear the CRISPR. Baby, take my splicer. Don't fear the CRISPR. We'll be able to braid. Don't fear the CRISPR. Baby, I'm your Mendel. La, 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 gattaca.
Do you see what I'm doing? That was the cowbell.
Oh, yeah.
Gattaca. I love that. Whoever
So,
wrote that.
thanks, Internet.
Oh my goodness. Thank you, Internet. That is
Wow.
brilliant.
I thought I was being original, you guys. I'm really
Blair.
bummed.
I found it. Look.
Wow. Twinsies.
Ah,
Both of you with your broken mic stand.
we found the weak link.
Ah.
That's it right there.
Yeah, I thought I was being all original with my spoof, but apparently not.
No, I thought you were very original, but somebody got there first, and I am.
Darn it.
I'm excited by it. It's pretty awesome.
Nothing I ever do is original.
We'll be able to break.
I should just go to
Don't
bed.
fear the CRISPR now.
Said
Baby,
every
I'm your
artist
Mendel.
ever.
Yeah. Someone else has done a
La,
calendar,
la,
I'm sure, just like mine.
Actually, no,
Right,
it's
just
classic,
like yours.
classic. I always think this because I come up with the same thing. I come up with an idea and then somebody does it. But then, like, I was watching Caillou today, and he was trying to come up with what he was going to draw for the art project. He's like, I think I'll draw me and my daddy washing the car. And somebody's like, oh, somebody's doing that. And he's like, oh, the good ideas are taken. And I'm like, yes, exactly.
I cannot stand Caillou. Sorry.
You know what? I couldn't either, and
Caillou.
my youngest currently is a bigger fan than the other two kids were, and pretty good show.
At least, the characters are nice to each other. That's all I care about. Like,
They're nice to each other, and they were they have like a lot of helpful, 2-3-year-old ideas that they put out there. That pretty good.
I'm a big fan,
Pretty good.
not having any children of my own, of Yo Gabba Gabba.
Yo
I love
Gabba Gabba
Gabba.
had a very important message for my
That's
second
great.
child.
What was
There
that?
was this
Try
song,
it, you'll like it.
Don't bite, don't bite, don't bite your friends.
I remember that one. Yep. Don't bite your friends.
She was a little chomper. She was a little
my
goat
God.
show. She would like come up and like like she's gonna kiss you and then like
Ouch.
try to eat you. So
I liked,
that's my
try
child.
it. You'll like it. Try it. You'll like it.
I like
There's
all
a
of them.
party in
Yo
my
Gabba.
tummy. It's yummy. It's
It's
yummy.
yummy. There's a party in my tummy. I love that one. There's a party in my tummy. Oh, Yo Gabba Gabba songs.
And then Elijah Wood did the Puppet Master, and I was like, this is the best show ever.
It is. They brought in some really good people. I remember the first time I was like, oh, they have celebrity cameos. This is amazing.
Yeah,
Okay,
and then like weird indie rock bands on too.
Yeah,
Right.
so cool. My son now is into, I'm blanking on her name, but it's some female children's song singer lady. And I'm actually, I don't know, I might have to start my own female singer-songwriter for children band because I know it's just songs and it's supposed to be fun and kids like them, but it's like the lyrics. She has a song about going into space. It's about a rocket ship, and it's it's catchy. 5, 4, 3, 2, 1, blast off another rocket ship run. 5, 4,
yeah. I've got that album somewhere.
blast off another rocket ship run. Rocket ship run. Yeah, but then she goes into space, and then it's like it's just all wrong scientifically. And I'm like, this song is teaching my child. It's catchy, so the child's going to remember it, and it's wrong.
Yeah.
And there's another song on the album about dinosaurs. Wrong. In many ways. We're dinosaurs. We walk and we make the earth flat. And I'm like, what?
What?
That is just
Wait, the earth
so
is flat?
Yeah, it's so confusing in so many ways. It
I
just
don't remember that song. It might not be on the mixtape I have.
I don't know, but it's fun, it's catchy, these are great songs, and I'm like, yeah, catchy, and so wrong. I can't deal with that. He likes it. I can't deal with it. What do I do? Do I write to her and say, rewrite your songs, please? I've rewritten your songs to be more scientifically accurate.
No, what you do is you take, what is it, a CD? You take the CD. You go,
What
hey,
are these
Kai,
things?
hey,
This
Kai,
old technology.
look at this.
I just break it. He'll never
Don't
listen
cry.
to it again.
Don't you dare cry. It's not real. It's fake science. Get it together.
I'm not
And
breaking.
you're like, Blair, never, ever have a child.
Ah,
You can't have this stuffed animal. It's not anatomically accurate.
rip the head off. Rah.
The thing my kids are now really getting reintroduced to and enjoying a lot is Marx Brothers movies.
yeah.
So good. I used to
One of
love
the
those
things-
when I was little.
Yeah, one of the things I got the boyo this year was a big collection of Marx Brothers movies.
What's his
And-
favorite? Duck Soup?
Oh, Duck Soup is our longtime favorite, for sure.
The best one.
So
Duck
Blair,
Soup is classically the one. It's got to be the best. Although there is, and I think it's Day at the Races. There's a whole scene
That one's really
in
good.
there about needing one more book. With the book with this is the book of the horses. Okay. But it's no good without the jockey book that goes with it. What's that?
Mhm.
That's another dollar. It's like keeps going. He keeps having
Right.
to get another. But yeah, fantastic stuff. And I realized, like this is like the gift of gab. You know, this is what the Marx
Yes.
Brothers.
So what's Sebastian doing?
he wants to ask you why
Yeah.
you would slap a lobster on somebody's wrist.
Why would you slap a lobster on somebody's wrist?
Isn't that what you said in the show notes? I was so confused by this phrase of yours. To turn a phrase. By fitting praying capuchin monkeys punished those that received a disproportionate amount of food without having been provoked. Don't we all want to slap a lobster out of someone's hands on occasion? Okay, I read
Yeah.
it.
Yeah, there you go.
Slap a lobster out of someone's
Yeah,
hands.
you can't eat that.
No, I don't have. Well, you know what's funny about the lobster?
I read it too quickly and I was like, why would you put a
Yeah,
lobster
funny.
on
Lobster slap
someone's
bracelet.
wrist?
What's
Yeah.
funny that you say this because lobster was once considered poor people food. Rich people.
Yeah, because they were detritus eaters. It's gross. But it's like caviar, too. It's like, I think caviar is disgusting, personally, but it's like one of the most expensive things you can eat. Or how about snails?
Once upon a time, it was poor people food.
Yeah, and snails,
Snails
too.
Snails too. Who with any money would eat a snail? Ugh, no.
Yeah, there's a story that I think is just press releases were just out on insects are the most sustainable high-density food for getting omega-3s.
Crickets. Eat
Going
your
into the
crickets,
future.
people. Eat your
There's
Eat your omega-3s. Eat your insects.
There's a Bay Area company called, what's it called? I think it's called Tiny Livestock, and they make various things out of mostly mealworms, but other insects. And so they make, for example, flour out of mealworms. So
I've made cookies out of mealworm flour before.
Yeah, so it's just flour that has really high protein and good omega-3s. And
Yeah, it's good for you. Ed from Connecticut posted a link that I was going to talk about, but didn't on tonight's show. UK scientists ready to genetically modify human embryos. If you read the study, it's not that they just want to make designer babies. That's not what they're doing. They have put forth a proposal to the British science, I don't know what, the British science overseers, I don't know, whoever's in charge of that. And
The Royal Academy of British Sciences.
and
pass the lobster.
and the proposal is
Put
to
some snail on it this time.
to use human embryos that are edited with CRISPR-Cas9 to remove specific genes for development to understand what the role of those genes. So the idea would be that we would take embryos, edit them with CRISPR-Cas9, let them develop for 7 days, and then destroy the embryo, to the zygote. actually just a blastocyst. So it would be the blastocyst stage to understand what certain genes have to do with certain developmental stages during the progression of the blastocyst. So it wouldn't be,
aka 10 cells grouped together.
yeah, so it's not designer babies or even really editing human beings. I mean, it's using, and these would be discarded blastocysts from in vitro fertilization efforts. So these would be they're just going in the garbage anyway. So why not use them for research? And then the reason they want to use CRISPR-Cas9 is because it is the most specific of the editing techniques that have been suggested for use previously. So they would maybe have to use fewer of the human embryos than other research would require. So it sounds like win-win-win-win-win to me, except that this is going to make people up in arms because it's using
oh, you're playing
cells.
God. Yeah.
Yeah, but it's not to actually have to
Actually,
edit
you're
something
playing
and have-
scientist, which is much more powerful.
It's
much
more fun.
It's more fun. Yeah.
Because it actually works.
Oh, burn.
Burn on you, God, believers.
What just happened
We
there?
can actually do stuff. What can you do?
Oh my goodness.
Nothing.
Justin, shush.
Soylent Blue in soup instead of crackers. Why are you guys talking about Soylent? Oh yeah, and Hot Rod. The Al Jazeera America network is shutting down. That's kind of upsetting because they've had a nice science tech show for a few years now that's been great, headed up by a few very talented individuals. I have friends. I have friends who work on the Al Jazeera America network, and I'm kind of sad that it's going to be going away. My friends got to get new jobs.
But there's a good reason for it. There's a good reason for it. It's because on the no-fly list, the suspected terrorist list now is an organization called Al Jazeera, and it is
What?
It's come to the attention.
No.
It's come to the attention of authorities in the United States, some of the congressional subcommittees on the sciences, that this Al Jazeera has infiltrated schools in the United States.
Justin.
And is therefore they need to take drastic.
That's pretty funny. He's making me laugh.
That was funny, Blair.
Well,
Shut up.
okay, no, but it's interesting because
Quit doing sign language hand symbols to my comedy act. People paid to see this, okay?
all right. Yeah, I should do this.
We went to a comedy club, and there was this woman in the front row who was like, every once in a while, get up and start walking onto the stage, and they bring her down, and she'd like say stuff, and they were like, stop talking during people's performance.
And she was doing this while they were talking. She
was doing like sign language at the end, where she's like a half 2 seconds behind it.
Yeah, it's terrible.
Yeah.
No, the reason I was talking is because last year one of my predictions was that math will get attacked in schools.
Right. That's right.
Your children.
So basically,
your children in school are being indoctrinated into algebra.
Algebra.
Yeah. So just like we were talking about a minute ago, there are no new ideas.
No new ideas. We
the
try.
laws of algebra are being taught to your children in public school.
And this is why I haven't written a book, because I look out and I'm like, these things are already out there. Why should I write a book? It's already out there. What new do I have to say?
All the good ideas are already taken. Somebody drew a picture of their dad washing the car with him. I'm just done. I'm giving up art.
Doesn't matter. All the good ideas. We just do it again. Do it better. Do it again and again and again. I think I'm going to have to listen to Blue Oyster Cult now for the rest of the week.
I think I'm going to have to play some cowbell.
CRISPR. On the moon, don't fear the CRISPR now. Come on, baby. You guys, we went to New York. Did we fill the room with our voices?
Nearly. Just a few shy.
A few shy.
You guys, you should have been there. Too bad you couldn't buy tickets because it was so full.
I know, so full. Where did Justin go?
He's dying. Yeah, it was like we totally filled the room.
It was packed.
It was so packed, like we could barely talk. It was so loud from the laughter and clapping.
That's right. We did have some great visitors though, from New Jersey, from Brooklyn, from
Chicken rats in a swamp.
I had a whole contingent from my high school.
a contingent from your high school.
Yeah,
That's
that was great.
awesome. Your
Yeah.
LOL contingent.
Lowell, let's go Lowell.
I thought it was your LOL, LOL.
Oh. LOW.
I was like, oh, you've got your own LOL
I went to
contingent.
what was the first public high school west of the Mississippi River.
Yeah, tens of people. It was nice.
Yeah.
Not huge, just nice. It was good. We had a nice little turnout.
I had a great time.
We had a great time. It was very fun. It was very, very fun. I know that we had a lot of people watching online. We had a good spike of people watching online, which is very cool. That was neat to be supported at home while we were away. So that's great. I gotta get better at the marketing thing.
You know, I think we should have a marketing intern.
A marketing intern.
I'm serious. Like someone who's in marketing, who's majoring in marketing. They could do a lot of things. Make graphics, run campaigns, find free methods.
Right.
I don't know.
That would be awesome.
I feel like there's got to be somebody out there looking for an internship in marketing. And then, you know, we just need to be able to give them some units.
Exactly. We'll give you credit.
Yeah. You're still qualified to do that?
Mhm.
Oh, well then yeah, we could totally do that.
Yep.
I mean, they could even do it remotely. It's not even something that they would have to meet you in person to do.
Yeah. Yeah. Well, that, I mean, to have an internships are, you have, yes. I have to, they're tricky. I don't have an HR department.
Right.
It's like,
but
how long did you have an intern where you're like, okay, it'd be nice if you did these things. That would be cool. But I'm not telling you to do it because I can't tell you to do it.
But I have quite a bit of experience managing interns too. So we could potentially pool these options, these things, and we could get something going. I think we could. I think it could be worth a conference call or two. I just feel like we could all do some more marketing, but it's like time is the variable that's really in rare supply, right?
Yeah, time, but it's also, so it's time, but it's, time going, okay, so how are we going to approach this particular thing? What's our strategy? Are we actually talk about it and make a plan and then do the plan?
Yeah, so maybe someone that like studies metrics and comes up with marketing tactics every day in their classroom would be someone that we could just try some stuff with. I don't know. I feel like it's something that we could potentially do.
Yeah. This is a pretty picture. You guys want to see a pretty picture?
Yeah.
It's a nudibranch. Want to see a
Chat.
I love
While you're
nudies.
about to do that, chat room.
pretty
Give
picture
me
of a nudibranch?
Nudie.
Chat room. Give me 3
Yeah.
quick cures for
He's
hiccups.
got like a butt
Yeah.
gills. That nudibranch has butt
I
gills
got cures.
or back gills.
Butt gills.
It's just I like it.
Oh
It's
my gosh.
kind of where would you imagine a butt being? It's like the butt gills.
Nudies don't have butts.
Well, I know, but what is that? Why is that there? That's a strange
For his
location.
gills. Have you ever heard of the book? It's this amazing photo book called Spineless. Oh, it's gorgeous. It's a photo book, and it has all invertebrates in it, and it has quite a few nudibranchs in there that are just breathtaking. It's an amazing photographer. I don't know. I guess she found ways to put black or white backgrounds behind very clean
Middleton.
tanks, I guess.
Yeah.
Yeah.
No. I want to look inside. Will you let me look inside? Let's look inside. Can we look inside? I found it.
I have a copy of it at work. I can try to bring it here next week.
Spineless. Looks pretty.
Yeah.
As a foreword by Sylvia Earle.
Uh-huh.
Ooh, suckers.
Suckers.
Big suckers.
Hot Rod just cured my hiccups. So here's the cure. Hold your breath for 10 seconds.
I have my own cure.
Count down to 1, holding your breath a little bit more for each countdown. And I just did it, and it worked.
What do you mean? I don't understand that.
Okay, so you go, and then you go 10, 9, 8.
Oh,
That's pretty.
look at that nudie.
Yeah. Cute little shrimp.
Sure.
Hot Rod, I did it, and it worked.
That's pretty. It's a pretty book you can buy on Amazon. How neat. That's beautiful. That looks pretty on Amazon. Susan Middleton's Spineless book. That'd be pretty cool. My cure is similar to that. The way that you get rid of hiccups, what you have to do is stop the spasming of your diaphragm. You hiccup because your diaphragm, that muscle, it's a thin sheet of smooth muscle that goes between your lung cavity and your abdominal cavity. It spasms. And so you have to stop it from spasming. And so you know how like when you get a cramp in your calf muscle, you want to like push that cramp out and like,
Right.
you know, extend your leg to try and get rid of the cramp. It's the same kind of thing. You want to extend that the diaphragm. So like what Justin did, he slowly expanded the lung cavity, and like by holding the breath and expanding, what you're doing is you're forcing the diaphragm to give more and more and more and more. And so basically you were doing the analogy of extending your leg and stretching out that calf muscle by your diaphragm.
Yeah, it
So
really worked. Thank you,
the
Hot
thing
Rod.
that- the
That's
thing
the
that-
first time I've asked for an immediate cure to something.
And it worked.
It worked.
Yeah, the one thing that I do, I hold when I do it, I hold my breath and then bend over. So it's like expand the diaphragm and then physically contract it by bending over at the
Oh,
waist.
interesting. Yeah.
And then holding my breath. So it's expanded and then kind of being forced in on itself. And hold my breath for 10 to 20 seconds. And it works every time. Every time.
Oh, video switching system that could get us off of Hangouts.
Not suitable for work.
No, that's the show.
The
Linux
show that-
Gamecast.
Thank you, Dr. Hot Rod. The bill will be coming later. Next one.
Yeah, thanks for the
That's
link,
tomorrow,
Ben.
Justin.
Oh, interesting.
Cool, yeah.
Huh.
Is this part of this? Is this a Steam thing? Or Twitch or something? I guess it's just Linux Gamecast. Ooh.
Interesting.
Yeah, I'll have to look into that. Cool. Thank you. No, Ed. Guys do not get diaphragms for hiccups. Yep.
Yeah, take the diaphragm.
Insert.
Stuff it down your throat.
Oh, can I? I'm gonna find something that I thought was very funny. And I have to share it because I think you guys will appreciate the humor. It's kind of like doctor's advice, but oh man.
I can tell you at some point during the tour of New York, went to this noodle joint that I very much wanted to eat the food, but I couldn't because I had a lovely lady on my right hand and a lovely lady on my left hand, and there was no way I could operate chopsticks with both of my hands.
You didn't eat?
No, I did.
I'm
That was
shocked.
just a joke.
I'm
That
shocked
was just...
you didn't eat.
No, that was a joke I heard from tonight's Marx Brothers. I retell it. I kind of failed.
What to do with your opinion?
Yes, I saw this. I did see this. Yes.
Can I hold on? I want.
This is also not safe
keep
for work.
talking because I want to see it.
This is also not safe for work.
This is it. What you should do with your opinion. Hold your opinion as small as possible. Lubricate your opinion with either water or Vaseline. Lie down on your side and bring your upper knee closer to your chest. Now stick your opinion as deep as possible in your rectum so that it will never come out again.
Oh.
Well, it is the two things that everybody has. Right?
An opinion and a rectum.
Yes.
That's right.
Rectum, I barely knew him.
I don't know. That just makes me laugh every time I see it.
No, seriously, since seeing that, I've this is, yeah, I've been thinking that about a lot of people's opinions.
I just want to tell people this now.
Really small as you like.
Fold it very, very small.
You can't fold it more than 7 times, okay? But fold it at least those 7 times, right?
That opinion, you just gotta keep folding it. It wasn't a dirty picture. It was a medical diagram. It was a medical diagram. It was not a dirty picture.
No. Not at all. Totally SFW.
Yeah, it's a medical picture.
Mm-hmm.
TWIS is always SFW.
Right?
Just not always in the pre-show or the post-show. Get a little dicey.
It gets more dicey, but still on the whole, out of all, it's more SFW than BuzzFeed articles, which occasionally one might read at work.
Or perhaps even political campaigns now. It seems as though they've gotten a little cursy.
Have they?
Oh, yes. Oh, yes. Oh, yes.
Who knew? All right, it's the stroke of 10, you guys.
This is funny. My dad just posted in Facebook. He says, watching the after program chat on This Week in Science, they were warning of the risks of algebra. It is a belief system that has infiltrated many of our public schools and a few advanced religious ones. The Persian poet, mathematician, and astronomer Omar Khayyam was a devotee.
They're coming for your kids.
I like what my dad picks up from this show. Yes. Hi, Dad, if you're still watching. All right.
Somebody found the humor in it.
That's right, somebody did. I thought it was funny.
I was saying it.
I thought it
Because
was.
I thought I was doing a funny thing a little bit. No shtick. All right. Tomorrow, no show.
Venn diagram. That's right.
Day after tomorrow, also no show.
No show. Wait, no. But tomorrow is the Science Island, the TWIS Minion hangout with Ed Dyer.
Which Kirsten is finally showing up to
Whoa!
after a long absence. So, Kiki, look forward to seeing you on the show.
What?
Um,
Why you do things like that?
Well, why not? Like, what's going on Thursday night?
Yeah, he put it in. He put it in the chat room. Thursday, 11 to 12 p.m. Eastern Standard Time. You can go to scienceisland.org.
By the way,
find
Kiki.
the chat.
By the way, Kiki. My
Just-
city just kicked your city's ass.
What?
My
Why?
city just kicked your city's ass.
Why did Davis?
Yeah, data came in on the city that has the most, by percentages, the most bicycle commuters.
Oh, okay.
Okay, yeah.
There we go.
You could call that winning.
Davis has always had the most bicycles per capita of anywhere.
Doesn't Davis have
Portland's been
more
kind of-
bicycles than people?
Yes.
Possibly, yes.
There's something like the 2.5 kids. People in Davis have 2.5
our
bikes.
bicycle commuter ratio was something like 22% of the population commutes, as opposed to a mere 7% for Portland.
That's all I
So-
did in Davis was ride my bike.
My city
All I
just
did.
kicked your city's butt on something. Eat it, Portland.
All right, I'm gonna
San Francisco
start cycling more.
San Francisco didn't even show up on the map.
No.
Grrr.
Yeah,
Because-
that's because you're going to get hit by a car.
Yeah, the only people on bicycles are like the delivery guys who are crazy and ride
Yeah.
the single speed fixies and stuff, and it's like ah.
And people with a death wish, for sure. I knew someone that worked for me when I was at the aquarium who, I think in just the 2 years I was working there, I want to say she got hit by a car 3 times going to and from work on her bike.
3 times?
Mm-hmm.
Bah.
Yeah. Yep. And the last time she got this huge settlement, and I was like, okay, so you're going to buy a car, right? And she goes, no, I'm just going to buy a nicer bike.
I'm just gonna buy a nice. Okay.
All right.
All right.
Okay.
Don't get hit by a car again. Tomorrow night, Thursday, Science Island hangout, and then we'll be back next Wednesday. We don't have any big crazy things happening. It's pretty cool. Ooh, we made it through the holidays. We made it through the holidays. We made it past New York City.
Andrew estimated Portland a little bit. Davis comes in at 23.2%. Total commutes made by a bike. Portland was 7.2, not 7%, 7.2.
There we go. 7.2. There we go. Doing it and doing it. Excuse me, I have the yawns. All right. I have a few calendars left if you haven't bought your calendar yet, but I think we're down to like the last, maybe towards the last 10, maybe.
Ooh.
Maybe.
That's great.
Getting there.
Yeah, I was supposed to take some from you, and
And then I went
we
home with
didn't-
the bag, and then we didn't.
I know we didn't make the handoff.
I know. It's okay. Darn it. Darn it.
But orders are
you
still
guys.
trickling in. So if any of your
trickle,
friends are
trickle.
like, "Oh man, I still don't have a calendar,"
Get them a calendar.
twist.org.
That's right. Calendar man. We got calendars, man. We got your calendars.
Mhm.
I'm going to go to bed. I think I'm
Yep.
tired.
Good night.
It's
Kiki.
Bedtime.
Yeah. What I do is, and I got some editing and things to do this week. I'm going to see what I can do. One of these days, I'm going to try and edit your little short. Yes.
Yeah, maybe one of these days I'll try to learn how to do that. But so far, neither of us are winning that race.
I know. I
You know how I was like, oh, well, you can go ahead and try, but I'm sure I'll be able to get around to it at some point. Just whoever gets to it first. Yeah, I shot that October 3rd.
Yeah.
Whoops. We're
gonna be
busy.
We
We're
are.
busy.
Busy people.
Yeah.
Say goodnight, Kiki.
Oh, and next Thursday's Squirrel Appreciation Day.
Oh no! Okay, I will
Say
find a
goodnight,
way to
Blair.
celebrate.
Well,
Good
we
night,
can
Blair.
celebrate.
Say
We can
goodnight,
talk
Kiki.
about chubby squirrels next week.
Great.
About chubby
Say
squirrels.
goodnight, Kiki.
Good night, Kiki.
Good night, minions. I'll see you next week.
Good night, everyone. We hope to see you again next Wednesday. Thanks for watching. Bye. Oh, wrong button.